Hi everyone, welcome to the course on microsensors and nanosensors. We are going to start our ninth module where we are going to discuss occupancy and motion sensors, and this is the first lecture of this ninth module. Basically we are talking about two different sensors, occupancy and motion. So we have to first understand that how they are related and how they are different. Okay. So when I talk about occupancy sensor, they are basically used to detect the presence of individual. It can be some animal or a person or some object in some designated area which I am monitoring, or the area which is at surveillance. Okay. However, a motion detector or a motion sensor responds only to the moving object. Okay. I hope that this difference is very clear to you. When I talk about occupancy sensor, they are used to detect the presence. The presence can be at still position or it can be moving, okay, but in the designated area which is under the surveillance. Okay, and motion detectors respond only to the moving objects. Okay, so the difference between the occupancy sensor and the motion sensor is that occupancy sensor generates signals whenever an object is stationary or moving in that particular specific area. However, a motion sensor or a motion detector are selectively sensitive to the object which is under movement. Okay. So I hope that it is very clear that how they are related and how they are different. Okay. They are related by means that occupancy sensor will also give signal when the body is under motion or body is under still, okay, in that particular area. So it just tell you that the object is there in that particular area or not. Okay. However, a motion sensor only deal with the moving object. Of course, if you are able to detect the motion and if you can locate that area, you can tell that the area is occupied, okay, or it can also be called a occupancy sensor. So they are interrelated to each other. Okay. So that's why we are covering it under one module. Okay. So there are different occupancy and motion sensors, and again, as similar to our other modules, the principle of these sensors are very similar. It can be based on ultrasonic principle, it can be based on some microwave principle, there can be capacitive occupancy and motion sensors. There are certain reports on triboelectric based devices that we are going to discuss in this course, and we have some optoelectronic based devices which is based on visible or IR spectra. Okay. However, ultrasonic and microwave devices are very popular, and of course the capacitive and triboelectric seconds them. Okay. The application of occupancy and motion sensors is enormous. Okay. For security purpose, for example, say you are sitting in one room and that room belongs to someone and they want to monitor that the room is occupied or not, for example. Okay. Or you can say that there is some private area which has to be monitored, that no one should enter that particular area. So for security reason, this kind of sensors are very, very important. Okay. Particularly for surveillance applications. Okay. For energy management, for example, electric light control. So if you talk about smart buildings, you might have seen that there are certain buildings when you travel from a certain corridor, some lights will glow, and when you leave that area, those lights will be off. Okay. So these are occupancy and motion sensors which are controlling these lights, that if that area is occupied, then only those lights will glow. Okay. So in energy management, these devices are very popular. Okay. For personal safety, home appliances, point of sale advertisement, okay, interactive toys, in all these applications, these sensors find its application. Okay. So depending on the application, human presence can be detected through methods that rely on some properties of human body or action of the body. Okay. So occupancy sensor or motion sensor can be built which is sensitive to, say, body weight. It can be sensitive to body heat. Okay. The sound that we create or the dielectric property of the body. If I want to make a surveillance system to detect a human, okay, so I have to use some parameters from the human body itself. Okay. So I can utilize a body weight. For example, say the room that I was talking about, okay, if someone is entering and if I have a hidden, say, weighing balance, okay, or a mat which can monitor the weight of the person, okay, that mat, if it is integrated with Wi-Fi modules which can transmit the data if the weight cross, for example, anything above 40 kg, okay. So if something which is above 40 kg is moving inside the room or which is entering into the room, the mat will transmit that data, okay, and I can say that what I am using is I am using the body weight as a characteristic to monitor the occupancy or motion of the body. Okay. Similarly, if I have, say, a thermopile sensor, array of thermopile sensor or any other heat detector at the gate, for example, okay, and if something is crossing and the pattern of heat that is being recorded by this array of sensor changes, I can say that something has moved inside the room. Okay. So by this also you can develop some occupancy and motion sensor. Similarly, other parameters can also be utilized of the human body to monitor its presence or absence. Okay. So let us try to understand that how these common material properties can be utilized to develop these sensors based on different transduction techniques. Okay. Let's understand it first from, say, air pressure sensor. Okay. So when I talk about air pressure, you already have understood the pressure sensors in the previous module. Okay. Say I have air pressure sensors installed in the door itself. Okay. So what happened that this door, the pressure sensor can monitor the changes in air pressure which is resulting from doors or window opening. Okay. So when the door is closed, there is certain pressure. Okay. And when someone open the door, okay, the pressure changes gradually. Okay. Or sometime if it is sudden open, so pressure changes suddenly. Okay. So these change in the pressure can be considered as a data that the place has been occupied. Okay. So this pressure sensor, the air pressure sensor, can be used to monitor the occupancy or the motion of the object towards the room. Okay. Or say if somebody has occupied the room and if it is going out, the change in the air pressure can tell that the person has left the room. Okay. Similarly, capacitive. Okay. If I talk about capacitive, the human body's capacitance itself can tell about the occupancy by that particular person or not. Okay. Then you have acoustic sensor. So if I am in the room and I am whispering something, if the room has multiple acoustic sensors available, okay, the acoustic sensor can detect the speech, okay, and it can tell that the room is occupied by someone. Okay. Then say you have photoelectric devices. Okay. So if there is a interruption of light beams by the moving object, so if I have say multiple lights, monochromatic lights, or even if it is a broadband spectra, okay, placed in the room, and if some object is moving in the room, okay, and there will be a change in the pattern of this light. Okay. There will be some interruption of this beam. Okay. So you have photoelectric devices which can detect this interruptions, okay, and can tell about occupancy or motion. Okay. Then you have optoelectrical devices which detect the variation in the illumination or optical contrast in the specific area. We will discuss about optoelectronic devices in this module in more detail. Okay. Then there are pressure mat switches. Okay. So these are pressure sensitive long strips which are used to on the floor beneath the carpets to detect weight of the intruder. Okay. So in the room, if I have a carpet and beneath the carpet if I have pressure mat switches, okay, if the person is walking, I can detect the pressure because of his movement, okay, and I can comment on his movement pattern as well as the occupancy and motion of in that particular room. Okay. Then you have stress detectors which are basically strain gauges which are embedded into floor beams or staircases or other structural components with which the person can interact. Okay. Then you have switch sensors these are electrical contacts connected to doors or windows. Okay, so these switches can tell that the door was opened or not opened. Okay, then these are electrical switches. You can also have magnetic switches. These magnetic switches are a non-contact version of the electrical switches. Okay, then you have vibration detectors which react to the vibration of the walls or other building structures that is attached to door or window to detect the movement. Okay, then we can also have a glass breakage detector. These sensors react to specific vibrations which is produced by the shattering of the glasses. Okay, so if someone is intruding the room by breaking the glass, I can have glass breakage detectors which work on the frequency of this shattering of the glass. Okay, and it can tell that, okay, this glass has been broken or not. Okay, then you have infrared motion detectors. These devices are sensitive to heat waves emanated from warm or cold moving objects inside the inside the specific area which I am monitoring. Okay, then you have microwave detectors which are active sensors, and they are responsive to microwave signals which is reflected from the object. So you have a transmitter for the microwave, you have the object through which it is reflected, and then you have a receiver. Okay, on the same principle, you have ultrasonic detectors also, but there you are transmitting the microwave, but here you are transmitting the ultrasonic waves. Okay, then in general we have video motion detectors which are nothing but video equipments that compares a stationary image stored in a memory with the current image from the protected area. Okay, then you also have same video motion detector but as a face recognition system, where the image analyzers compare facial feature with the database. So here the complete photograph is not compared, but only the facial features, but more detailed features are compared with the intruder's feature. Okay, or the database. Okay, then you have laser system detectors which is very similar to the photoelectric detectors, and they use a narrow light beam and combine the effect of different reflectors in the room. Okay, then you have triboelectric detectors which are capable of detecting static electric charges which is carrying by the moving objects. Okay, so these are different ways and different ways of detecting the intruder by using various transduction techniques that are available in this electrical domain. Okay, including the, of course, magnetic as well as the triboelectric and microwave techniques. Okay, so what we will do is we will first try to understand one of these principle, and we will start with the ultrasonic occupancy and motion sensor. It will do is it will also help us to understand the microwave occupancy and motion sensor, because the principle will remain very similar. Okay, so ultrasonic waves we all know that are mechanical acoustic waves with frequency which is beyond the upper limit of human hearing, which is anything around 20 kilohertz. Okay, so when these waves is incident on an object, a portion of their energy is reflected. Okay, and some is of course absorbed and other things, but then some portion is reflected, and these sensors are based on this reflection. Okay, in many practical cases, this ultrasonic energy is reflected in a diffuse way. Okay, what it means is the diffusion reflection means that diffusion reflection is the reflection of ultrasound from a surface such that an incident wave is reflected at many angles and not only one angle. Okay, so it is just opposite to the specular reflection, where we expect the reflection to be at only one angle. Okay, so you have wide angle of reflection. This is the way the ultrasound reflect from an object. We call it diffuse reflection. Okay, so regardless of the direction from which the energy comes, it is reflected nearly uniformly over a wide solid angle, and this solid angle can be as high as 180 degree. Okay, so if the object is in motion, the frequency of the reflected wave will differ from the transmitted wave. Okay, so the two frequencies will be different. Okay, and this was given by Doppler's law. Okay, or this is called as Doppler's effect. Okay, so the Doppler's effect refers to the apparent change in the frequency of the wave which results from the relative motion between the source of the sound and the observer which is observing this sound. Okay, and the aberrant frequency in the Doppler's effect can be determined by the equation which says that the object frequency is equal to the actual frequency into the velocity of sound plus minus v naught, which is the velocity of the observer. We will see what this sign means and when we have to take positive or when we have to take negative, divided by v plus minus vs, where v is the velocity of sound wave in the medium, v naught is the velocity of the observer, and vs is the velocity of the sound. Okay, and f is the actual frequency. Okay, so v naught, please note that this v naught is positive. This is observer. So v naught is positive if observer is moving towards the source, and this v naught, this term actually v plus v naught we have to take when it is moving towards the source, when the observer is moving towards the source, and it has to be negative or it has to be v minus v naught when it is moving away from the source. Okay, and it is just opposite in case of the movement of source. So vs is positive if it is moving away and it is negative when it is moving towards. Okay, please remember this. V naught is positive if moving towards the source, vs is positive if moving away from the observer. Okay, so this is very important equation, and based on this, based on the movement of the source and observer, you can have multiple cases. Okay, say the first case is if the source is moving towards the observer which is at rest. Okay, so the perfect example can be a person. Okay, this person is at rest waiting at a railway platform. Okay, and this train is coming towards him. Okay, so in this case the observer is at rest, and of course this train is making some, it is blowing some whistle. Okay, it is blowing some whistle and it is coming towards this person who is standing on a platform of a railway station, for example. Okay, in this case if you see, this f bar from the Doppler's effect will be v plus minus v naught by v plus minus vs into f. Okay, in this case the observer is at rest. Okay, and source is moving towards the observer. Okay, we have seen already that vs is negative if moving towards the observer, right? Therefore, in this case I will have, since he is at rest, v naught is 0. Okay, f dash will be v by v minus vs into f, right? Second case can be if the source is moving away from the observer at rest. Okay, in that case you have to take it negative. Okay, then you can have the third case if the observer is moving towards the stationary source, and in that case it is positive. Okay, so you have f bar equal to v plus v naught by v into f. Okay, there can be multiple cases where source and observer both are in motion and other things. Okay, so the idea behind these sensors is very simple. You have transmitters that emit ultrasonic pulses. Okay, then you have receiver which reads the reflected signals. Please note that I am talking about ultrasonic pulses and not the ultrasonic signals. I am talking in the signals in the form of pulses, which is very important. We will see while we will discuss the construction of a ultrasonic occupancy and motion sensors. Okay, so the idea is very simple. You have a transmitter which emits ultrasonic pulses. you have receiver which reads the reflected signals, and there are some provisions to compare the echo patterns. This can be based on simple microcontrollers, okay, or by some other devices which can take the decision that what is the receiver, or which can compare at least the transmitter and the receiver signals, okay. So for moving person, larger change in the echo time and intensity. For stationary person, for moving person, when I say, I mean to say the motion sensors, and for stationary person, which I want to say the occupancy sensor, there is slightly disturbance in the signal, okay. So basically you can use these ultrasonic sensors for both the cases. It may be more accurate for moving person, it may not be that accurate for stationary person, but still you can have some disturbance in the ultrasound, okay. So now the idea is, as I have mentioned, is very simple. You have a transmitter, there is an object, and you have a receiver. You transmit the signal, ultrasonic sound in pulses, and it is received, and you have a control circuit which can take decision that or which can compare the receiver and the transmitter, okay, received signal and the transmitted signal, okay. So the distance L naught to the object through the speed v of the ultrasonic wave in the media with the angle theta can be calculated as L naught is equal to Vt cos theta by 2, where t is the time for the ultrasonic wave to travel to the object and again back to the receiver, okay. So L naught is equal to Vt cos theta by 2, okay. Now if I consider this transmitter and receiver are, placed very close to each other, means that I have this transmitter and this receiver, it is going from here and it is coming back, okay. You have cos theta equal to 1, okay. So you have L naught is equal to Vt by 2, okay. So ultrasonic waves offer various advantages if you compare with the microwave, which is our discussion in the next topic, okay. Since we are discussing the ultrasonic devices, they have certain advantages over the microwave to be utilized for these applications. Of course, we will see some limitations also of these devices, but ultrasonic waves travel at the speed of sound, right, which is significantly lower than the speed of light at which the microwave propagate, okay. So when your speed is less, okay, you have longer time to monitor it, okay. So the measurement becomes very simple, as well as it becomes the cost effective. You do not have to acquire different lenses, electromagnetic lenses to deflect this microwave kind of electromagnetic waves, okay. So it gives you considerably larger time to monitor, and that's why the measurement of this ultrasonic waves are simpler, okay. So the generation of any mechanical waves, including ultrasonic waves, require the movement of a surface, without which you cannot generate this kind of wave. So this movement results in compression and expansion in the medium. This expansion can be in any medium, it can be in solid also, but it is more prominent in case of fluids like gases and liquids, but of course it is possible in solids also. For example, consider this case. Here the applied input voltage make the ceramic element flex and transmit the ultrasonic waves, okay. This is, please note that this is possible in the piezoceramic element, okay. So when it flex and it is removed, because of its movement, you have ultrasonic waves, okay. Of course the diaphragm is made up of metals, okay. Now you know that the piezoelectricity is a reversible effect, okay. The ceramic produces a voltage when incoming ultrasonic wave flex it, okay. Now the element can function as sonic or ultrasonic transmitter as well as the receiver, which is basically a microphone which is detecting the ultrasonic wave. Okay, since this is piezoelectric material, it can behave in both the way. Okay, it can generate the voltage, as well as if you receive the ultrasonic wave, it can also generate the voltage. So when you apply the voltage, it can generate the mechanical waves, and when at a receiver, when it receives the ultrasonic wave, it can also generate the voltage. Okay, so basically you can use the same element for transmitting and receiving. Okay, because if you have seen, we have considered a case where transmitter and receiver are placed very close, and it is sometimes it is so close that basically it is a single unit. Okay, and I also have mentioned that we are transmitting it in pulses. Okay, so if this is the pulse, okay, if this is the pulse I am talking about, in this pulse width or in this pulse time, say this is some microsecond, you are transmitting, so the same unit is transmitting the ultrasonic wave. While it will be off, that time it will be receiving this. So you have transmitted, the time it takes to go to the object and it come back to it can be compensated in between this, right? So in one pulse you can say that it is transmitting, here it is receiving. Okay, so the same unit can be used for both the purposes. Okay, so usually its operating frequency for transmission is nearly 32 kilohertz. So mostly these devices work around 32 to 40 kilohertz. Okay, now the impedance characteristic of this piezoelectric transducers are shown over here. So this is impedance, the y-axis. Okay, and this is the frequency. Okay, this is the impedance and this is the frequency. Okay, this is the resonance frequency and this point is the anti-resonance frequency. You can see that the sensitivity of the devices is very high at the resonance frequency, and that's why I have mentioned that most of the piezoelectric ceramic materials has resonance frequency around 32 kilohertz. Okay, and so you can expect around 32 to 40 kilohertz to be resonance frequency for these devices. Okay, and at resonance frequency you have highest sensitivity of the devices, and that's why most of them work around this. Of course, the impedance is minimum at this. Okay, so for optical efficiency, the frequency of the driving oscillator should be adjusted to the resonance frequency of this piezoelectric ceramic. Okay, so at this particular frequency, the element exhibit maximum sensitivity as well as maximum efficiency. Okay, so in pulse mode operation, the same piezoelectric element can be used for transmitter and receiver, as we have discussed. Okay, so the advantage of these devices are they can detect stationary occupancy as well as the movement. Okay, so for stationary occupancy, we have seen that there will be slightly disturbance in the ultrasonic wave, while for movement, okay, while for the movement you have this kind of the change in the frequency pattern. Okay, then it covers moderate area with wide detection angles, as the transmission we have seen is in the diffused way, or the reflection is through by the diffused way, there is a large angle of reflection, and that's why the detection angles for this kind of devices are very large. Okay, it works in dark or visually obstructed ambient. Okay, and they are silent and non-intrusive. They have non-intrusive operations. Also, if I talk about from the fabrication point of view, it is not that difficult. We have seen that making this kind of diaphragm structure is not that difficult. Okay, of course, it has to be integrated with oscillator and other things, which is sometimes challenging, but fabrication is not a big deal in this case of ultrasonic devices. Okay, however, there are certain limitations, and that's why people has moved to other kind of devices. Some of the limitations can be like false trigger can happen due to, say, even air movements. Okay, then sound reflection in the irregular rooms its pattern is little bit different, and sometime it can result in the false triggering. Okay, then these devices are actually power hungry devices. If you see, you are giving considerable amount of voltage to generate this ultrasonic waves, so they are not a power efficient devices. Okay, and they are less effective when you walk in the open ambient or as well as noisy ambient, because the ultrasound waves are low frequency waves and it can interact with the ambient. Okay, that's why we have other kind of detectors in place like microwave motion sensors. Okay, so microwave detectors are ideal for application which require coverage of large areas. Okay, so they perform reliably over wide temperature ranges and under harsh conditions like harsh wind condition, noisy fog conditions, dusty ambients, as well as high humid conditions. Okay, so electromagnetic waves are actually backscattered or reflected by the object whose size are compared or even larger than the wavelength of the incident signal. Okay, so the reflected waves are detected, then it is amplified, and then it is analyzed to to get insight about the object from which it is reflected. Okay, so the distance to an object is measured by the time delay between the transmitted signal, which is also known as the pilot signal. Okay, so the time delay between the transmitted signal and the reflected signal, is used to measure the distance of the object. Okay, the object speed is determined by the frequency shift of the reflected wave. Okay, so the object speed is determined by the frequency shift of the reflected wave. So you are basically using time delay as well as the frequency shift, so it gives you more control over the accuracy of the device. So microwave devices of course are far more superior as compared to other kind of devices. Okay, so these microwave detectors are well established method and they belong to the category of devices which is known as radar, which we all know that stands for radio detection and ranging. Okay, so there are various bands of microwave motion sensors or microwave basically. Okay, so you have K band, X band, C, V, L, P, different bands are there. Okay, which has different frequency range. Like for K band it is 26 to 40 gigahertz, for K it is 18 to 26.5 and so on. Okay, so the term microwave is arbitrarily assigned to the wavelength which is shorter than typically 4 centimeter, which correspond to K and X bands. Okay, they are basically long enough to pass easily through most contaminant, the contaminants like clouds, moistures, dust and all. Okay, that's why it is, we have already seen that radars are basically based on these devices. Forget about the occupancy sensors. Okay, so it is short enough to be reflected by the large objects. Okay, so based on microwave principle, we have microwave motion sensors which are very similar in operation as compared to the radar. If you are a microwave enthusiast, you might be knowing about operation of radar, how it works. Okay, we'll see our microwave motion sensor which work very similar to the principle of radar. Okay, in the next class we will be talking about microwave motion sensor and some other occupancy and motion sensors that we have to cover are capacitive devices, triboelectric devices and so on. Okay, so we'll meet in lecture 2 soon. Thank you.